Okay, grade 8, lesson 99, inverse variation and direct variation. Direct variation you've learned about before, and I'll give you a good example of this, or an easy example of this. If we have x and y, and x is 0 and y is 0, x is 1 and y is 3, x is 2 and y is 6, x is 3 and y is 9, you can see that if I go 3 divided by 1, I get an answer of 3. If I go 6 divided by 2, I get an answer of 3. If I get 9 divided by 3, I get an answer of 3. So this is an example of direct variation. Right? So you could do kx equals y, or you could do y over x equals k. K is your constant. Okay? Inverse variation is what we are looking at today. That's a little bit different. Okay? So if you were to look at an inverse variation, you would get something like this. 1 and say 10, 2 and 5, 3 and some fraction, probably 3 and a third, 4 times, I don't know what it is, 1.25? No, 2.25. 2.25 it is. Sorry, I'm trying to think of what it is. 3, we'll just delete 3 out of there. That might not be the best example. 4 and 2.25. Now the whole example here is that when you multiply 1 times 10, you're going to get 10. When you get 2 times 5, you're going to get 10. When you get 4 times 2.5, oh boy, I'm still doing it wrong. 4 times 2.5, you're going to get 10. So you can see that if we go x times y, we're going to get your constant. Okay, that's really what they're talking about with direct variation. With direct variation, you will not have 0. You'll never have a 0. And the reason you'll never have a 0, because 0 times something will never equal 10. Okay, so that's where you see an example of direct variation where that will not work. Okay, so let's go to the practice set, and maybe that will help you figure this out. So when you look at direct variation, for example, the first problem that they give you is y divided by x equals k. What's that an example of? Well, we talked about that earlier. If you look at the beginning, y divided by x equals k, that is an example of direct variation. Okay? Another thing to know about direct variation, we're going to see that, is it'll be able to go through 0. Very easy to see. Right? So let's go to B. We have, for B, x times y equals k. And that would be inverse variation. How is your graph going to look for inverse variation? Well, it's going to have a curve. And it's going to go up, and it's never going to touch the axes. Okay, which gives you an example for the next two. C shows you an example of direct variation, and D is going to show you an example of inverse variation. Inverse variation, never going to touch the y or the x-axis. Okay, so E is asking you the next question. It says, for E, and I'll read this, it says, determine if the variables in the table 1 and 2 are inversely proportional. All right, and describe how you made that explanation. So I'm going to draw this up so we can work our way through this. X, Y, right? So we have a 1 and a 6. We have a 2 and a 3. We have a 3 and a 2. Easy test. 1 times 6 is 6. 2 times 3 is 6. 2 times, and the last one was 3 here. 3 times 2 is 6. So is this one? Yes, it's inversely proportional. All right, so that gives you the first one, and that's for number 1 there. For number 2, let's go take a look at the second example. We have 1 and 3, we have 2 and 2, and we have 3 and 1. Again, same kind of thing. We have m and n. So we know that m times n should equal a constant. 1 times 3 gives us 3. 2 times 2 gives us 4. 3 times 1 gives us 3. So no, that was not inversely proportional. All right, so if we move to F, it says it takes 3 people. It takes 3 people 5 hours to complete a job. How long is it going to take 5 people? This is inversely proportional. So it's going to say if we grab the 3 and we multiply it by the 5, we get to 15 hours. Excuse me. The same thing works here. So we know that we have to equal 15 on this side, and you'll see that the solution is it's going to take them 3 hours. Okay, the last one, G, asks the question. It says the volume of air in a balloon and the air pressure in the balloon are inversely proportional. If the balloon is squeezed to half its original volume, by what factor does the air pressure increase? Okay, so let's just grab some numbers. The balloon and the AP. Right? So if the balloon and the AP equals 1, then it doesn't matter which way you're going to go. So if you're going to squeeze the balloon to half of what it was, right? So if the balloon is 2 and the air pressure is 2, right? Then our answer here is going to be 4. And now we're going to make the balloon, half its size, so make it into 1. That means that air pressure has to be 4 in order for this to work. And so you notice that between these two numbers here, what's our scale factor now? Our scale factor is 2. We've doubled it. Hopefully that makes sense the way this all works. What I'd like you to do, grade 9, is make sure that you do every other one. So do the odd ones in the exercise. I will be available on Google Meet at 9 o'clock or any time that you have a question. It's very easy. The Google Meet code is on the top of the class. Remember to mark your work for lesson 98 and submit it with a comment in the private comment